Hi everyone, let's look at some examples of adding and subtracting rational expressions. So step number one would be to factor completely all the denominators and then determine the lowest common denominator. They're connected, so we need to factor them in order to determine what the lowest common denominator is. Now remember that denominators cannot be equal to zero, so while we're at it, we can state the restriction, lowest common denominator, different than zero. And then we have to make all rational expressions with the same denominator, so they are prepared and ready to add and subtract. Then we combine the rational expressions into a single rational expression. Then we want to factor the numerator to see if we can simplify the final expression a little bit more and simplify at the end. So let's take a look at an example. In the first example, we have x over 2x minus 4 minus 3 over 3x minus 6 plus 1. So step number one, we'll factor the denominators. As you can see here, we have number 1, which is not in fraction form, and we're going to write that as 1 divided by 1 so that we'll be able to see the denominator. So the first fraction will be, a rational expression would be x 2 times x minus 2, and then we have 3 over the factored form of 3x minus 6 is 3 times x minus 2, so you have a common factor of 3. And number 1 will be written as 1 divided by 1. So now that the denominators are in factored form, then we will find the lowest common denominator. As you can see, x minus 2 is a common factor, so we list that only once. And then we have a factor of 2 and a factor of 3. And that makes the lowest common denominator equal to 2 times 3, 6. And since this is a monomial term, we want to write this first and then the binomial term. Now, right after you state the lowest common denominator, we take care of the restrictions. So the restrictions will be the denominator cannot equal 0, and the only part of the denominator that will make the denominator 0 is the factor x minus 2. So we're going to say x minus 2 different than 0, therefore x has to be different than 2. Now our job is to make all the denominators the same. So 2x minus 2 will have to become 6x minus 2. 3x minus 2 has to become 6x minus 2. And number 1, 6x minus 2 as well. So we have to think, what do we have to multiply this by in order to obtain this denominator? What is this denominator missing to become same as lowest? And what is this missing to become same as the lowest common denominator? So let's get to work. I first like to write the expression the way it is. And I'm going to leave a little bit of room in every fraction, rational expression, so that I can multiply by the missing factors that makes the denominator same as the lowest common. So for the first one, 2x minus 2, we're missing a factor of 3, so 2 times 3 is 6. And then x minus 2. So we'll multiply numerator and denominator by the same number, 3 over 3, which means that we're practically multiplying the entire fraction by 1, or the entire rational expression by 1, which means that we're not changing the value of this rational expression, as we're not supposed to. So in the next denominator, we have 3x minus 2. So here we're missing a factor of 2. So we'll multiply both numerator and denominator by 2. And lastly, we have just 1, so we're going to need 6x minus 2 in here. So we'll multiply both numerator and denominator by the entire lowest common. Now, as you can see, the lowest common denominators are the same, but we're going to rewrite this expression one more time, a little bit more neatly. So we have 3 times x over 6 times x minus 2. So 2 times 3 is 6. And then minus 3 times 2, 6, divided by, this is now 6 times x minus 2. And then plus, we have just 1 over 1, which will turn into 6x minus 2 over 6x minus 2. Now that all denominators are the same, we will add and subtract fractions or rational expressions here. So, which means that we are simplifying the numerators, bringing them together, simplifying numerators, and the denominator will stay the same. So first things first, the numerator, 3x minus 6 plus 6 times x minus 2. So this is where we expand 6x minus 12, and all this will be over 6 times x minus 2. In the next step, we'll keep on simplifying that numerator. So 3x and 6x, 9x, negative 6 minus 12, negative 8, and that will be over 6 times x minus 2. So next step is factor the numerator if possible. And the reason why is because even though this is, completely added, so we have finished adding and subtracting, we need to write the final answer in the most simplified form. And the way we simplify is by recognizing or identifying what the common factors are. And we can identify the common factors if the expressions are in factored form. And that's the reason why we need to factor the numerator. So we're going to check and see. And that's not going to be the case all the time. Sometimes numerator is not factorable, but we always have to check, right? So in this case, we have a common factor of 9 and then x minus 2 divided by 6x minus 2. So as you can see in here, x minus 2 is a common factor, which means that it will simplify, and 9 over 6 will also reduce to 3 over 2. And this would be the most simplified form of the given expression right here. And don't forget that once you simplify, beside it, separated by a comma, we gotta state the restrictions. As you can see here, some of the restrictions will disappear, and in this case, the only restriction we had disappears, but we need to make sure that we write this in our final statement. Now let's take a look at another example. You can try this on your own, obviously, or you can follow along. It is your choice. So always read the question first, see what you have. You have a rational expression, you have a constant number here, and then you have another rational expression. So you are subtracting and you're adding here. So we're going to start off by rewriting the expression, and hopefully we'll be able to take out the common factor or write the factors of the denominators. So write denominators in factored form. So we're going to start off with, first of all, 4x minus 1 over 5x plus 25. Oops, sorry. So this would be equal to 4x minus 1 over 5 times x plus 5 in factored form. And then we have minus 3. 3 has no denominator, but we're going to make the denominator visible by simply writing 1. 3 over 1 still equal to 3. And then plus x plus 3 divided by 3x plus 5. So 3 is a common factor. Now, as you can see here, we have a common factor of x plus 5. 5 and 3 are not common, so that will help us determine the lowest common denominator as 5 times 3 times x plus 5, which is common, and in a more simplified form, the lowest common denominator will be 5 times 3, 15, and then times x plus 5. Since we are at the lowest common denominator, we'll state the restrictions as well, and the restrictions are the only part that can make this denominator 0 is x plus 5 being 0, so we're going to say that x plus 5 has to be different than 0, which makes x different than negative 5. This would be the restriction. So now let's take care of our expression, make all the denominators the same. So we're going to start off by writing every single fraction, and I like to leave a little bit of room between each fraction so that I can multiply by whatever is missing in the denominator. So we make it same as the lowest common. So 5x plus 5 is missing the factor of 3 to become a 15. X plus 5, so we'll multiply both numerator and denominator by 3. Now remember, when you have a binomial here, it has to be inside brackets because the number 3 will multiply the entire numerator, and this is how we make this happen. So we write the brackets and then multiply by 3 so that 3 multiplies each term. Now 3 over 1, so denominator of 1 is going to need the entire denominator of 15x plus 5. So we multiply by 15 times x plus 5, both numerator and denominator. And lastly, x plus 3 over 3x plus 5 is missing 5, so we're multiplying by 5 over 5. Now we're going to take care of this expression, write it in a simpler form. And that means that here we have 12x minus 3 that would be over 15x plus 5. And then we have minus. We multiply by 3 by 15 and then x plus 5. So I'm going to take care of 3 and 15 first. So 45 x plus 5. And then over 15 x plus 5. And lastly, we have 5 times x and 5 times 3, which will give 5x plus 15 over 15 x plus 5. So next, we can bring all the terms together in the same denominator, but check and see first. We have 12x minus 3, and now we have 45x plus 5. Now remember, this negative sign will belong to the first monomial here, and when the 45 multiplies x, we have to consider the negative as well. So negative 45 times x, negative 45 times 5. And that's why I color-coded this in purple so that you can see it, that it is this negative sign that we had in here, right? That is participating in this multiplication. And then same thing, negative 45 times positive 5, that is going to be negative 225. And lastly, we have plus 5x plus 15. When we have a plus, nothing changes, so you just add 5x and 15. And in the meantime, I highlighted the like terms to make it easier for us to simplify at the end, and everything will be under the same common denominator of 15x plus 5. Now continue on. We're going to collect like terms. You don't really have to bring them together in an extra step, just highlight them and add together. And what we have in this case is 12 and 5 makes 17 minus 45, negative 28x, and the numerical terms are negative 3, negative 25 to 25 plus 15. So negative 225 plus 15 is negative 210, and then minus 3, negative 213. And this will be over 15 times x plus 5, which is our common denominator. Now, if you look at negative 28 and negative 213, they do not have any common factors, but traditionally, whenever we have the first term, which is also called the leading term in an expression, with a negative coefficient, we take that negative sign out. So you can either state the final answer as negative 28x minus 213 over 15x plus 5, comma, the restriction, or we can take out the negative 1 and then rewrite this as negative 28x plus 213 and then divided by 12x plus 5 and then state the restriction. So I would accept both answers as correct. So this is sort of in standard form. This is more factored form. It's just a negative 1. But there is one very important note that I want to emphasize. Now, whenever we are stating the final answers, and I must mention that the rational expressions that we work with are sort of at the simple to medium level. It is very, very, but this note becomes more important, especially when we have, even more complicated rational expressions. It is very important that your denominator always stays in factored form. And the reason why we want to keep the denominators in factored form is because at the end, we always look for that factored form of the numerator, because we always look for possible common factors of numerator and denominator. And when they are in factored form, so denominators are in factored form, then they are in what we call ready to simplify form, right? So never expand the denominator, and we always want to keep it in factored form, or as we want to call it, in a ready to simplify, if possible, form. So I hope this made sense. I hope you enjoyed the explanations. Thank you for learning with me, and bye for now.